Okay, in this video we're going to be taking a look at a very important concept in economics, whether it be microeconomics or macroeconomics, and that is the concept of elasticity. And to understand what is meant by elasticity, I thought I'd start by a very simple example. So let's take a look at a simple example of what we mean by elasticity. Okay, so in this example we're gonna go to the blackboard here. And we're going to take the case of somebody who's working in a store. So we have a simple store over here. We got a store, and the person is selling goods and services in their store. The price of, let's say, I don't know, shirts, let's say, the price is equal to, let's say, 10 euros, and the store owner is currently selling, let's say, 100 shirts. Okay, so currently revenue is equal to, well, 10 times 100, so they're making about 1,000 euros in shirts. Now the question is very simple. What happens if the store owner decides to cut the price? So let's say we cut the price with a discount of 10%. So we have a 10% discounted price. So the new price, let's call this price new, is going to be 9 euros. Big question, is the store owner going to make more money or less money? Well, you could say, well, they're going to make less money because they're going to be selling the shirts at 9 euros each, and they sell 100, so we expect them to make 900 euros in revenue. But we also know that as prices fall, people buy more. So it all depends on how responsive the demand, the quantity demanded is as this price falls. Will quantity go up maybe a little bit? Will quantity demanded go up a lot? And in this case, hey, you know what? Maybe that price decrease actually resulted in much more being bought, and the quantity demanded is very responsive to this decrease in price. Well, let's suppose that the quantity demanded goes from 100 to, let's say, I don't know, let's say it goes up by 20%. So it goes to 120. So it rises by 20%. Well, in this case, what's going to be the revenue? Well, the new price is 9. The new quantity demanded is 120. And so we get 9 times 120. We get 1,080. So revenue actually rises. Now, this is pretty easy to see because the percentage change, or the drop in the price here, this is a negative change, is more than compensated by the 20% increase in sales. And this is what we'll call an elastic demand, because the percentage change in the quantity demanded, which is equal to 20, if I divide it by the percentage change in the price, in this case was negative 10, I get overall a number. If I take the absolute value of this, so I get rid of the negative value, I get 2, which is, we'll see in a second, greater than 1. So we have an elastic demand, and we expect that the revenue increases. Now this may not be the case, right? Maybe the quantity demanded went up by less than 10%. Maybe the revenue won't go up, as we saw in this very simple example. So this is the role of elasticity. We know if we can decrease the price or increase the price, or decrease the price, pardon me, by a small amount, and see what happens to the quantity demanded if we know what the elasticity is. Let's go back to our slide. Okay, so elasticity is an economic concept that measures the responsiveness of one variable to changes in another variable. And in this example we gave, we looked to see how the quantity demanded would respond to a change in the price. And this is what's called price elasticity of demand. We could have looked at the percentage change in the quantity supplied, and that would have been the price elasticity of supply. So we calculate a ratio, and we determine if something is elastic, more or less elastic or not. And as you saw in that previous example, the elasticity, if it's greater than 1 in absolute value, because in this case we know that the prices fall and the quantity demand goes up, so the ratio is negative. But we always measure elasticities as a positive number. If the elasticity is greater than 1, then we expect a high responsiveness, which was the case we saw before. If, however, it's less than 1, it is referred to as an inelastic demand. Okay, it's less than 1, and we have an inelastic response. So we either have an elastic response or an inelastic response, depending upon if the ratio we calculated was greater or less than 1 in absolute terms. And if we go back to our example, we saw again here that this ratio, the percentage change in quantity demanded, it went up by 20%. The percentage change in price was down 10%, so the ratio 20 over 10 is greater than 1. It's an elastic demand. Now, if it had been something else, imagine that we keep the prices the same, but oops, pardon me here. Now, if we go back to the example we had before, we came up with an elasticity that was greater than 1. It could have been less than 1. What would happen? Well, we started with our original price equal to 10, and the quantity demanded was equal to 100. We decreased the price by 10%, so we dropped it by 10%, taking us to a new price of 9. The quantity demanded, well, what happens if it only goes down 5% to, let's say, 95? So this is a decrease, or pardon me, we increase by 5%. We decrease the price, we're going to add more, right? So we go to 105, let's say. We go up by plus 5%. Well, here we had a revenue of 10 times 100, which is 1,000. Here we have a revenue of, well, 9 times 5 is 45. 945. So we have 945. So revenue is going to go down. Now we can see this also if we measure elasticity. It's percentage change in the quantity demanded divided by the percentage change in price, and we take the absolute value of this. Here we have plus 5, and here we have minus 10, or 1/2, which is less than 1. So this is what's called an inelastic, relatively inelastic demand. Okay. We don't see a lot of response. We decrease price by 10%, but price only goes up a little bit. That's an inelastic demand. And if that ratio were equal to 1, we would have what's called a unit elastic, or unitary elasticity, which is when it's equal to 1. Now there are other elasticity measures that exist. We've changed the price and we've looked at the quantity demanded. We could also change the price of a different good. We could change the price of a substitute. We could change the price of a complement and see how it affected the quantity demanded of a particular good. So if we change the price of good B, which is maybe a complement, how will it change the quantity demanded of good A? That's what we call a cross-price elasticity. And income elasticity would be how much the quantity demanded changes if we change income. So if your income goes up by 10%, will the quantity demanded go up by 10%, less than 10%, or more than 10%? Now, the point elasticity can be calculated along a demand curve, and here we have a demand curve for some good or service, and we can calculate the elasticity as we move from point A to point B, and this is what's called point elasticity. So I'm going to show you how we calculate this as we move from point A to B using point elasticity. Okay, so now I've duplicated on the chalkboard what we saw in the previous diagram, and we're going to calculate the elasticity as we move from point A down to point B. This is the direction of the calculation. This is our old value over here, the old value, and this is the new point on the demand. And here we have quantity and euros or price up here. Okay, so let's calculate elasticity. So elasticity is simply calculated as the new quantity minus the old quantity, all divided by the old quantity. That's the percentage change in quantity demanded. And we're going to divide it by the percentage change in price. So the new price minus the old price divided by the old price. That's percentage change in quantity demanded over the percentage change in price, and we take the absolute value of this. So let's do it. The new quantity as we move from A to B is 90. The old quantity is 60, and we divide that by 60. Divided by the new price. The new price is 75. The old price was 100, and we divide this all by 100, and we take the absolute value. What does that equal to? Well, 90 minus 60 is 30 divided by 60. 75 minus 100 is minus 25 divided by 100. This is equal to 1/2 divided by 1/4. Absolute value of those values. So we get 1/2 times 4/1, which is equal to 2. So we have an elasticity of 2, meaning that this demand at this point here in the demand curve has an elastic response. And I've calculated that already for us, and we get the exact same answer as expected. Now there's another way to calculate this, and it's by changing a little bit the denominator. Instead of using the old values, we can divide by the average of the two. And this solves a problem, because as we calculate elasticity of moving from A to B or from B to A, if you use this equation, you'll get two different answers. So by dividing by the average quantity or the average price, you get what's called the midpoint elasticity. And that's for your information. And we get a slightly different number, okay, because we're going to not divide by 60 here, but by 75. And we're not going to divide by 100, but the value of 175 divided by 2, the average of the two numbers. Now, demand curves can be more or less elastic, as you can see. Here I have a case where we've got a demand curve, and I'm going to see if I can animate this. So if we're on D1, we're down here at D1, and we have a change in price. So the change in price, we can see the price from going from PA to PB. So price looks like it's going up about 50% maybe. Okay, so we have this increase in price. What happens to the quantity demanded? Well, as prices rise here on this demand curve, okay, we can see that the percentage change, the percentage drop in the quantity demanded is quite small. Okay, so this demand curve looks like it's not very elastic. We increase the price of a good and people buy less, but not a lot less. Whereas this demand curve here, which is much flatter, the quantity demanded here will go from QA all the way down to QB, which is down here. So it decreases by much more than even 50%. We have a big decrease in the quantity demanded. This demand curve here is more elastic than the other demand curve. Okay, so we can see that some are more elastic. This curve here is more inelastic than the other one. Okay, so one's more elastic, one is more inelastic. And if these were two separate demands and two separate products, why would that be the case? Now, it could be two separate demanders for the same product. We may have, for example, how much people are ready to pay for a new car. Okay, so you could have, well, the demand of young people, maybe, people that are just starting their job, and as the prices go up of the new car, they don't buy a lot of new cars. Maybe people that are older with a very stable income, their demand is more inelastic. But it could also be the product. Some products are more inelastically demanded than others. For example, if we require a certain good or we're addicted to a certain good, for example, well, the demand will be more or less inelastic. So a lot of things determine the level of elasticity. Are there a lot of substitutes? If we have a lot of substitutes, as the price goes up of a good or service, you know what? I'll go buy the substitute. So we'll see that elasticity goes up if there's a lot of substitutes. A small change in price and everybody leaves. What if it represents a large part of my budget? Imagine rent is a large part of my budget and the price of it goes up by 10%. Well, I'm going to try to find very quickly a substitute. So I'll be much more reactive to a change in price if it's a large part of my budget. If I see that I have to spend more, I'll probably try to change. And so we see that it becomes more elastic. Necessities, however, if the price goes up of a necessity or of an item that I really can't do without, people that smoke cigarettes a lot or if the price of cigarettes goes up, will they cut back a lot of their consumption of cigarettes? Probably not. And so necessities means that we have lower elasticity. Time plays a role in the determination of elasticity as well. If we have time to search for substitutes, we'll probably have a more elastic demand. Brand loyalty obviously lowers elasticity. Companies can increase the price and you don't decrease quantity demanded a lot. And also who pays. If my parents are paying and giving me the money to buy something, obviously it's more inelastic. I won't respond as much if there's a change in price. There are polar cases. If the demand, we saw in the previous example that a demand that was like this was more inelastic, and as it became flatter, it became more and more elastic until we get to perfectly flat, where it's infinitely elastic. You can't increase the price. If you increase the price, nobody buys. So this is an infinitely elastic demand, and this is infinitely elastic supply. So we have elasticity that's not flat, but straight up and down. So if prices change, quantity demanded does not change at all. And here we see in this example, if I have a price, let's say here, well, I buy this quantity right here. If price goes up or down, does my quantity demanded change? Not at all. So it's inelastic, perfectly inelastic, or elasticity equal to 0. Now, elasticity in pricing obviously has an impact, and we saw that already. It determines, if a change in price will have an impact on revenue. Now, elasticity also has an impact, and this is why it's interesting in macroeconomics, on who pays a tax. Imagine we raise a tax on some product, and here we have supply and demand, and we're looking, for example, at cigarettes. And the company is currently selling, let's say, a certain amount of cigarettes at a certain price. And if we impose a tax, if we have a tax of, let's say, €2 per pack or something like that, the company will want to make more. If I say, hey, you know what, we're going to add a tax to this price of €2, to sell that quantity, I'm going to want the price plus the additional €2 to cover the tax. So the suppliers will basically decrease their supply to include the tax. For this quantity, well, you know what? I want the price here, plus I want an additional amount that the tax is to cover the price of the tax. This is a move left or upwards of demand. That's a decrease in supply. What does that mean for the tax incidence? So let's take an example, a very simple example. I have supply and demand of cigarettes. We have 100 packs of cigarettes being sold, and they're selling at 10 euros per pack. And now let's suppose that we put a tax on the suppliers, the people who sell cigarettes. So we put a tax of 2, which is what we've seen before. Okay, it goes up by 2. But the final price actually only goes to 11. Well, why is that? Well, in this case, we can't make the consumer pay the entire amount of the tax because the demand is not perfectly inelastic. And we can see that the sales price will go now to 11, and we sell 80 packs of cigarettes, but the tax was 2. This means that, in fact, the supplier, we sell it at 11 euros per pack. 2 euros is taken away, means the supplier keeps 9 euros for him or herself, and this 2 euros is then sent to the government. The consumer pays 11, the producer keeps 9. They're making 1 euro less than they were before. The consumer is paying 1 euro less than they were before. And the tax is shared between the suppliers and the demanders. Now, this sharing of tax will depend on the shape of demand. Let's take the same example if we had an inelastic demand. So here we have the total tax revenue. We have 2 euros taxes times this number sold. That's the tax revenue here. What happens if demand is inelastic? If demand is inelastic, and this is the case for a lot of products like cigarettes that have taxes, they usually have a very inelastic demand. Here we have the same tax. The price goes from 10 to 11.75. Okay, the consumer pays 11.75, almost the entire tax of 2. And the producer receives 9.75 after they send the 2 euros to the government for the tax. So if the demand is inelastic and a tax is put on a good or service, it's the consumer that's going to pay the largest percentage of the tax. That's how we determine the tax burden on the consumer or the producer. So in this short video, you've learned about the elasticity of demand. You've learned what an elastic versus inelastic demand looks like. We've looked at the case of perfect elasticity and perfect inelasticity demand. And lastly, we've seen how taxes and the tax burden is shared as a function of demand elasticity.